Hey, B and Alex, how are you guys doing? Hope you had a good spring break. Hope you had a good Easter yesterday. We're going to get started here and work on another way. Hang on, my phone's ringing. We're going to work on another way of finding the area. Last time we did it by the summations. This time we're going to use the limit definition. Okay, so it's going to be just a little bit different than what we were doing. So example 1 here, let me give you a little a picture of what this might look like. If you have a graph, x cubed looks like this, but it says we're bound by the x-axis, so it's only above. And then it says the line x equals 0 and x equals 1. So it's really just like none of this, none of this, and none of this. It's only that little area right there in between, if you can kind of tell from my picture. Let me draw it a little bit better. It's a shape about like this. Okay, so last time what we would have done is we would have put a bunch of little rectangles in there and found the area of all of them and then added them all up. Okay, so today what we're going to do for the summation is we're just going to pick one rectangle and we're going to run with it. Okay, so what we're going to do is we're going to say, again, we're going to find the summation from I equals 1. We're going all the way to n because we don't know how many of these we're going to end up with. But what we need to do is we're going to say we want to do, after we get it all done, the limit as n goes to infinity. Okay, because if we do one triangle, it's not going to be real accurate, but if we do 2 triangles, it's going to be closer. 3 would be closer, 4 would be closer. If we run it all the way to infinity, we're going to get real close to it, and it's going to be so close that it's basically it. Okay, so we're going to do the summation of that to the limit as n goes to infinity, and let's see, we want to do basically our function and then times the width. So let's pick the width for our triangle. Okay, so my overall width of my piece here is 1 because I went from 0 to 1. Okay, so I need basically however many rectangles I decide to do, I'll divide that 1 by that many rectangles. So my width of each rectangle would be 1 divided by n, because n would be however many I choose. So in order to find the height of that, I'll plug it into the function. Okay, so my function in this problem is x cubed, so I'm plugging 1 over n for that, and then I'll multiply by 1 over n. This is finding the area, okay? That's finding the area of one rectangle, basically, if n is 1, okay? Because I'm saying 1 over n is the width, plug it into the function x cubed, okay, gives me the height. So then multiply them together, length times width, that gives me the area, okay? If I up n to 2, okay, then I have more of these. And if I do it to 3, then 4, then 5, and I'm going all the way to infinity with my limit, okay? So I'll start multiplying some stuff together here. If I do 1 cubed and n cubed, everything's getting its own, let me change this. This 1 on top should really be an I, okay? Because that's how we're cutting it in half, okay? So everything's getting its own cube here. We got I cubed, n cubed, multiplying it by 1 over n. So that's really I cubed over n to the 4th. So n's a whole number here. And remember, if we're doing summations, we can take that to the front. So what I really have is 1 over n to the 4th of the summation I cubed, okay? And I'm going from 1 to n, okay, which in our case we chose as infinity, okay, but we're going to still stick with n. So then basically all I got to do, I'm just going to run n through my problem, okay? Instead of choosing a number at the top, okay, instead of choosing like 5 and then doing the formula for I cubed, I'm just going to use it for n. So the formula for I cubed would be n squared times n plus 1 squared all divided by 4. N is my top number, okay, so I'm still going to have n squared times n plus 1 squared all over 4, okay. I've still got my 1 over n to the 4th out front, and this is all still to the limit, don't forget. Limit n goes to infinity, limit n goes to infinity, and Once we multiply here, we're going to be in real good shape. Okay, so if I multiply all that stuff on top, okay, if I FOIL n plus 1, then distribute the n squared, you can do that math on your own if you really want to. And then once I multiply the 1 over n to the fourth into it, yeah, I end up with three separate pieces. I end up with 1/4, 1 over 2n, and 1 over 4n squared. That's if I multiply everything out, all of this stuff right here, multiplying it out and splitting everything into its own denominator. Okay, so this is where I end up. This is still limit as n goes to infinity. So now I'm going to actually apply the limit. So applying the limit to 1/4, there's no place to put the infinity in, so it's just 1/4. This second part here, I've got 1 over 2 times infinity. Okay, so putting a number on the bottom, increasing a number on the bottom, makes it smaller and smaller and smaller. So anytime you're going to plug in infinity into the bottom, that basically represents 0, because that number is going to get so small that it's irrelevant. Same for our second piece right here. Okay, so once I add all those together, I've found the area under that curve. So it's a 1/4 on this problem. Let's take a look at another problem. Okay, let me give you a rough sketch of this graph. 4 minus x squared, that's flipping x squared upside down and moving it up 4 places. And you know we're cutting it off at the x-axis. X equals 1. Okay, so really this curve comes on down. We're just not we don't need it. So x equals 1, and then we're bringing it all the way over to x equals 2. So it is this space in here that we're trying to find. That is the one that we're trying to find the area of. Okay? So again, we're not going to set up a bunch of rectangles. We're going to set up one, and then we'll use the limit. We'll just send it all the way up. It's like we're using the 1, and then 2, then 3, then 4, then 5. Okay? So I'm going to do the limit again as n goes to infinity. Okay? And I'm going to set up a summation from 1 to n, right? And then I've got to think, okay, so again, this is only 1 wide, so because this is 1 and this is 2. Okay, so it's only 1 wide, so the width of each rectangle is going to be 1 over n. So that's definitely my width. Okay, but then I've got to be able to find the height. So that would be plugging the 1 over n, or the I over n, into the function. Okay, that's going to look like this. 4 minus 1 plus I over n, oh, yep, squared. I did not leave myself enough space there. Okay, so that's what it would look like plugging it into the function. Remember, the function again is 4 minus x squared. Okay, and that would be our x. So then multiplying everything together, first of all, making the left side look better first, this left piece, I would have 3 minus 2I over n minus I squared over n squared. Okay, that would make that look best. I've still got to multiply that by 1 over n. So then, remember, we're still taking a summation. And one of the great things about summations is we can give them all their own summations. So I'm going to skip a couple steps here. Remember, we're still limit here. I'm going to skip a couple steps, give everything its own summation, and simplify it as much as I can. So we've got, oh my goodness, sorry. So we've got the limit as n goes to infinity of 1 over n times the summation of 3 minus 2 over n squared times the summation of I minus 1 over n cubed times the summation of I squared. Okay, doing out my summation formulas, that's going to output me, still again, we're doing the limit. Okay, so the first part will put me a 3. Okay, I've got minus 1 plus 1 over n, and then minus 1/3 plus 1 over 2n plus 1 over 6n squared. Okay, now let's take the limit. Okay, remember, anything on the bottom, anytime you put an infinity in the bottom, that's going to turn it to 0. So basically, this is useless, this is useless, and this is useless. Okay, so that leaves me with 3. I got a minus 1, and then I got a minus a 1/3. Putting that together gives me 5/3, and that is what the area under that curve is. Okay, so hopefully you were able to follow this. If not, ask me a question. You should be good. I'm going to zoom it back out here in case you want to take a picture of it. I got some problems for you today. Let's go with page 300. Numbers 47 through 56. Should be able to handle that. Get it to me by next Monday, and we should be good. Hopefully we get to see you guys soon. Hopefully we're coming back. I think it's on the downfall now, so we'll see what happens. Let me know if you got any questions.